So hello again. Just well, as we are running quite late today, but I think it's worth it, and we have a full day for this. So, as I said, the next block will have a more practical approach, and we will have Tyris and INECO showcasing us the practical use cases that they have developed and that they are currently implementing in their respective businesses. The first one will be presented by Txus Blasco. I'll explain you a little bit who's Tyris. Tyris AI is one of the partners of our project, of the European project in Digital Twins. They are a company based in Valencia, a very young company, but they're still fast growing because they are simply disrupting the market with the application of the new technologies, artificial intelligence, and development of software and development of solutions and based on artificial intelligence, machine learning, etc., to optimize processes, to optimize maintenance or predictive maintenance. And today we will have the pleasure of learning from Txus. Txus Blasco is, correct me if I'm wrong, he's a Master in Science in Mechanical Engineering from Universidad Politécnica de Valencia. He's also currently going through the hell of his PhD in data science and machine learning. He's quite an expert in that. And he joined Tyris quite recently in November. But beyond that, he has a very innovative and entrepreneurship spirit. He has made his own ventures and will show us what are they doing today at Tyris. Thank you very much, Txus.
Thank you very much. Thanks a lot. So, yes, I am Txus Blasco. My pronouns are he, she, or they, whatever. And I am an industrial engineer. I have a master's degree in aerospace engines, not in digital twins, but I could be working with you because I like this subject very much. And I am a student in a PhD for computer science, and my topic is uncertainty quantification of neural networks, this time applied for financial prediction. And currently, I am project manager at Tyris AI, and I wasn't always a data scientist. I was starting as an engineer working in the automotive industry. In fact, in my early stages of my professional career, I was working as a development engineer, not in the software field, but in the physical things. I was designing and building plastic parts for the automotive interiors. And now, well, I am working at Tyris, and I wanted to do some years ago a change in my career. So this is why I wanted to go through something more abstract, towards data. Well, many engineers are twisting their careers towards data, and that was my case as well. And that happened because I realized of this, because every company is a data company, whether they know it or not. Ford Motor Company is a data company. Eventually they sell cars, but they are a data company. Inditex is a data company. Mercadona is a data company. Even universities are data companies. And this is what we do at Tyris. We are an engineering company using artificial intelligence for the industry. What we are doing is helping our customers to understand that they could potentially, that they could exploit further their potential in data, that they could acknowledge their assets, data assets, and to push them further in and get the quality and the quantity of data and help them to be real data companies. This is what we do. Tyris AI is a subsidiary of a bigger company called Tyris Software. And Tyris Software is made of 100 professionals. And Tyris AI is the advanced analytics specialized company from Tyris Software. And we are made of 25 machine learning engineers, software architects, industrial engineers like myself, and PhDs in the artificial industry. And we work together to push further the challenges of the industry 4.0. And at Tyris, we know, not yet. At Tyris, we know how important it is to cover the whole data life cycle from the beginning to the end. And this is why we are treating and we are dealing with data sources from the early beginning, from the acquisition phase. We treat data, we squeeze data, we do whatever is necessary, and we extract the most relevant pieces of information so we could feed algorithms, we could feed models that we are making on our own. And finally, we provide end solutions to the industrial, our industrial customers. And to that end, we are based on 3 pillars. And these are the 3 pillars. The first one is data integration. What does it mean? It means that we go to the industrial environment and we connect our own sockets to whatever is there, machines, databases, IoT devices, whatever. And as an example, we are developing right now a project, European projects, in which we are connected to a plastic injection machine. And, well, plastic injection machine is made of one mold, which is made on 2 hubs, and the plastic injection is injected inside. And if we achieve this is a European project of research and development, but if we achieve this, we will be revolutionizing the way data is acquired and processed. Why? This is the example. We are reading pressure and temperature from the injection molding, and we are doing it through industrial protocols. This is, let's say, the first step. The second step is the data analysis and the model training. And this is where the cool things start to happen. These are, let's say, funnier because we build things that are that can be seen as what you see outside. It is artificial intelligence models that do things and make decisions on data. And in the example that I just posed, our model made by the consortium, it is a very big consortium made of more than 10 companies in all around Europe. Our model will be able to say something like, hey, I know that you have here pressure and temperature, so you need to know that the next part, the next plastic piece that you are going to take out of the machine is not going to be okay. It's going to be a failure in terms of quality. But not only that, in the last stage of the project, we need to achieve something like the model telling to us something like, I don't only know that your part is not going to be okay, but I know the combination of pressure and temperature, so your part is okay at the end of the process. And this is closing the loop. I mean, the model is telling us what are the parameters that we need to set in the machine. And this is why I was explaining at the beginning that I was an industrial engineer. I was spending weeks in the industrial environment trying to find the best pressure and temperature combination of parameters, and that was really difficult. It was trial and error, and that was just 10 years ago. And look at where we are now. We're able to say, okay, we have a model which is doing the work, not with the human outside the loop, but inside the loop. And finally, we do the system implementation. And this is closing the end-to-end product that we are delivering. We build dashboards, we build interfaces, so we can interchange information with the machine, with the models. Okay, and I'm going to be shorter than compared with my colleagues, and I was bringing several examples here, and what you are seeing here is a battery from an electrical vehicle, and what you see is an artificial intelligence model that we have done on our own. We don't reuse commercial models, existing models in the market. We use our own. So as you can see, this battery is inserted in a vehicle, but sometimes you need to understand that the operators are going so fast building the car. They are plugging the connectors, those connectors in the car, and sometimes they are not plugged correctly. The thing is that when the car is finished, and this is at the end of the production line, if somebody in the testing facilities are realizing that these plugs are not correctly plugged, it is a cost problem, because they need to dismantle the rear of the vehicle and try to find what is going wrong. I can see what is wrong here, and you could also as well, because if you see this connector is not correctly plugged. But I know it because I'm a human, but the machine, well, we train it so it is, let's say, easy for them. So it is correctly identifying those connectors that are rightly connected to the battery and those who are not. Let's go to the next example. This is my colleague Jordi, indeed. I will put it. We have developed another model that is detecting it is first detecting persons, it is then detecting vests, and then detecting the cap, the hats that my colleague is wearing. So this is a safety application. Sometimes in the industrial environment, some operators are taking out their vest, and that poses a safety problem. So whenever the model is detecting that there is a person there, but is not wearing the vest or not wearing the cap, it raises an alarm somewhere in the environment to say, hey, this person is not wearing the right PPE, the personal protection equipment. And also, I was remembering our Asunción was mentioning the GDPR, and you can understand how difficult is also this, because you need to identify people, but not in such a way that you can identify everything that is this person is doing in the environment. So this is a special case because it is a safety issue. But in other case, for example, in the case that I was mentioning before, with the pressure and temperature in the injection molding plastic, we cannot do things like creating a data set. We are gathering data every second, pressure, temperature, but we cannot do things like, okay, so from 8 to 12, there is one person working on this, and then from 12 to 4, there is another person, because that would pose a GDPR issue. But sometimes we need something similar to that, because sometimes we don't know why the labeling of the data sets are not the same. So, well, issues and challenges in the industry. I have another example here, which is stairs. This is a static camera in a commercial establishments, and as you can see, this person is doing something wrong. First, he was going up in the stairs, but then he was going on the other side, and that is detected as something that should not be happening. For example, if that person would be taking his arm outside the stairs, that would be raising an alarm as well. So this is the kind of things that that we are doing. Okay, another example. These are indeed my colleagues at the office. We were testing the models that we were building. I can tell you we're having fun. We work sometimes, but we are having fun. So as you can see, the model is detecting that one person is standing and one other one is sitting down in the floor. This can be used for detecting postures, human postures that could be harmful for the people, for the operators, for the workers. If I am acquiring a posture, a bad posture, a model can tell, hey, this person is not doing it right, so don't do that, stop doing that. And this is another example. This is an overhead conveyor system. This can be found in industries like, well, every automotive industry has a system like that. And this is like well, you have kilometers of the rail that this conveyor system is following. The thing is, and I wanted to show you this, not so you don't think that everything that we do is in artificial vision, but this is data. This is data prediction. We are analyzing, or the industry is analyzing electrical patterns in the conveyor systems, in these carts. And when the pattern is detected to be anomalous, then that particular car is separated out of the rails and it is repaired. And it is because every minute or every hour the industrial environment is stopped, well, they are losing millions. Imagine Ford is getting out 2,000 cars per day. So they cannot afford to stop 1 minute the line. This is very, very critical in terms of cost. Okay, so I'm going to go a little bit deeper in terms of technicalities. This is a pipeline. This is the typical pipeline that we implement in the industrial environments. And this is a plant, an industrial plant. We can get data in real time and process that data in real time from databases, our IoT devices, machines, whenever you can think of. And we are doing it through connectors, sockets, the blue thing. This is the sockets are made and are built by Tyris, and they are used for translating the data going through industrial protocols like Profinet, Profibus, OPC UA, OPC UD. Okay, and then we use big data approaches to treat that data, to process that data. The first ones are the first pillar that I just showed you before. And we are using stacks like, for example, Apache Kafka, Apache Hadoop, Spark, Storm, and those are, let's say, those are stacks that make people think that the most difficult thing in the data pipelines are the models, for example, the neural networks. But it is not true. the most difficult thing in data, at least in industrial environments, is acquiring and having labeled, usable, and useful data. It is, I mean, imagine and remember the videos that I showed before. I showed you before. We need terabytes of labeled videos to tell the machine learning models how to behave and how to be trained. And that needs to be manually, or maybe we need to use advanced analytics like data augmentation or any other technique, like for example, the generation of synthetics in data. And then we have the models. Then we have the neural networks. And we do them in Python. As I said, usually we don't use commercial models. We build them by ourselves because we make ad hoc solutions for the industry. So every application is different. So we need to start from scratch always. And finally, what we have here is once we have the output of the model, we can monitor the outputs and the responses from the artificial intelligence models in dashboards that we also build. We use things like Vue, for example, React or Django. So our client has a whole data cycle implemented in Plant. Okay. And well, we have seen several applications of machine learning in Industry 4.0, but how does it translate to digital twins in the civil infrastructure industry? Well, let me tell you something, and if you are going to retain something from my intervention, retain this. Industrial plants and civil infrastructure objects are exactly the same from a data perspective. So in such a way that I can do this. It is as easy as that because we have sensors. We are acquiring data. And also, well, it is, we have a manufacturing plant, and it is not static, it is dynamic, but a building, an infrastructure, it is also dynamic. And yeah, a building is alive from a data perspective. And there are always things happening. Don't think of a building, of an infrastructure as a concept, as static as a concept, which is used for conceiving the work, conceiving the building, and once the construction is finished, it is done, and it is not used anymore. Maybe in the past it was like that, but it is starting to change. It is becoming differently. And yeah, because buildings get old, infrastructures get old, so they are always changing. And now, with sensors, we can track those changes. For example, we have here, this is another project that we have done. It is a picture, it is not a video, but I have a video of this. We have done this with one of the most important construction companies in Spain. And what you are seeing is that they wanted two things. They wanted drones, and they wanted vehicles on the road that they could get and acquire visual data from the road. So this is the results. This picture was taken by a drone, and they can detect potholes, or they can say something like, and this is more interesting, even more interesting, like warning, there is a high CRT here. Something is going to happen in the future. Okay? So, yeah. So let's talk about the BIM. The BIM is representing, or traditionally, it was representing the past of an infrastructure. It is like a passport. It is a virtual representation of what happened in the past, and it is including technical decisions, design decisions, contracts, 3Ds in the best of the cases, but not always, and many, many things. But now with sensors, we can not only represent the past, but we can also represent the current state of the infrastructure, as in this case. At Tyris, we are able to acquire this data in real time now. And yeah, you can do things like, for example, to acquire data to say if there are cracks in the environment. Is there any displacement of the structure? Are there any water leaks in the building? Is maybe, I don't know, a luminous case in the building? And because we have artificial vision, we can take that information. We can take infrared images. We can take thermal images. Maybe multispectral images, X-ray, whatever. Even sometimes companies are talking about making chemical analysis in real time. And not only that, but also the big construction engines are starting to think, and I'm very glad that you spoke about that. They are tending to include models in the BIM, but this technology is not yet fully implemented, and it is staying in the research and development domain and innovation. We are starting to do that. I want to show you the video of the results. This is the model in action. This is what it is detecting. The white thing are the cracks and are not okay parts, not okay pieces of information that can be gathered in real time. Okay. So this leads me to something that in Tyris we like to call what-if functionalities. Well, a digital twin is a virtual machine, isn't it? It is something that is representing the reality, but not really everything. It is like a simple model representing the reality. And as such, we can simulate a normal behavior. We can simulate something that is happening to a bridge. But this is very interesting because with what-if functionalities, you can do things like simulate abnormal situations. So now that we have a digital twin, we have the BIM, we have sensors, and we have real-time acquisition of data, and we are in the time in 2024 trying to include artificial intelligence models inside the BIM, so we could represent what will happen in the future, but not in normal conditions, but in abnormal conditions. And this is not as easy to do because a 3D or let's say, traditional linear simulation is not enough. We need to implement advanced analytics so that is happening. But we still don't know how to do that. We are spending a lot of money in the Commission, European Commission, and they are funding a lot of projects trying to do that, trying to fit artificial models inside the BIM. And yeah, as I said, the industry is seeing the BIM as simulators. Simulators not only for the present, but also for the futures. And I can provide you with an example of a project that will start at Tyris this year, for example. Regarding a bridge like this one, you have the pillars. I am not an expert or an architect. I am in the industry 4.0, but I will try to explain what I know. We have the concrete pillars, and then we have like concrete platforms, and between them we have something called like shock absorbers, and they are made of neoprene. So one thing that we are trying to predict, is to link and make a model linking the traffic volume, like this one, with the predictive maintenance of the bridge. We are not trying to build a model to know if the bridge will withstand charges or resistance. This is something that we already know how to do. But we are trying to link that with cost. This is cost. I mean, if I need to take the traffic to a different road, so I could decrease the maintenance of a bridge, and instead of doing an analysis and a visual inspection of it every 2 months, if I can do that every year, I am saving money. So this is why the industry is going this way. So, as I said, we're at a very interesting point in time. Very few companies apply the technology in this way. And what can we do to push further the state of the art? What can we do to include all the artificial models, the sensors, and the digital twins together, these 3 legs of that table? Well, through research and development and innovation. And this is what one of the things that we are doing at Tyris. There is a program called Horizon Europe. There are many other programs, national ones, regional ones, but this is one really interesting from our side. And just to name a few, we have 2 projects that are ending right now. One is Teaming AI, and Teaming AI is trying to make a digital twin of the industry 4.0, including artificial intelligence models. So what are we trying to do? And I feel especially attached to this project because I was the development engineer in charge of trying to find the pressure and temperature combinations in that machine. So now that a machine is doing it, so what is my role? Some people think that, well, the humans are going to be replaced, but I don't think that's the case, to be honest. At least the European Commission, and at least in Europe, they are putting a lot of effort to keep the human in the loop, to keep the human in the center. So everything that is raised and funded by the European Commission still needs to have the human inside. So I, as a human, I am part of the model. I am part of the system, because, and you can see it in ChatGPT. ChatGPT is still not able to be autonomous. Sometimes it is silly. It makes, well, it has hallucinations, as our colleague was saying before. So we are still here. So we need humans to make interpretation of the results. This is why we cannot get out of the equation. The other project that we are doing is called XMANI. XMANI is still putting the human in the loop, and it is touching something called explainable AI. Maybe you have heard about that. And this topic and the other one that I'm going to mention, I guess that this is going to be one hot topic in the future from a scientific and technological point of view. Asunción was mentioning also before about explainable AI. Neural networks and other machine learning models are black boxes. It is very, very difficult for us data scientists to know why the model has made the decision it made. We don't know that because it is in a mathematical model inside, and there are many neurons inside, and every neuron is taking one decision and is making a tiny thing, but we don't speak mathematical language. We speak human language, so we don't understand what is happening here. So explainable AI is trying to open the black box and trying to let us humans know about features. For example, well, it's very difficult to say without a picture, but if I need to make a difference between a cat and a dog, I could be taking into account, for example, the size or the ears or the legs of the cat or something. So this is something that I, as a human, can understand. So this is one of the projects. And the other topic that and this is my feeling, okay? My feeling is that uncertainty quantification is going to be one of the legally hottest topics in the future. And what is this? This is sometimes ChatGPT is providing you with an answer. If you ask, it is providing you an answer. But is it a correct answer? How can you know? Because you don't know how it took that decision. How was the decision made? And uncertainty quantification is about coupling statistics and coupling machine learning together, so the output that we have is understandable from a, let's say, uncertainty point of view. For example, instead of predicting points, or instead of predicting concrete things, trying to predict confidence intervals. And this is especially critical in medical devices, for example, or maybe, well, you come from construction. Maybe there's a parameter which is critical. So it is not enough to have one single number. If I am going to predict the behavior of a pillar or something, I don't want to have just one number. I want to have a tolerance. I want to have a confidence interval. So uncertainty quantification is a way to let the humans know whether how sure or unsure is the neural network about the result that it is making. And just to finish, Horizon Europe is one of my favorite programs because it is, it is very, very interesting from many points of view, technical point of view, also, of course, economic point of view, but it is really pushing Europe to the next level. And they are, of course, financing things and financing projects like that are treating CO2 reduction in the infrastructure industry, circular economy. I'm just naming a few so you could have that in mind because you will, of course, deal with that in the future. Sustainable development, increased human safety. And the type of projects that companies like Tyris is presenting to European calls have to do with that, with increased safety. And if we can have a drone, if we could have sensors when construction is being built, if an infrastructure is being built, we are taking the human outside the dangerous things, the dangerous spaces. This is one of the possibilities. And yeah, that's it. This is the end of the presentation. I hope you enjoyed and it was like practical enough. And please let me know if you have any questions.
Thank you very much. Some questions on these applications of artificial intelligence. Xavi, Pachi, this is your field. Okay, that's fine. Thank you very much.
Thank you.
And give the word to Alex to present to INECO.
So, hello everybody. My name is Alejandro Fedaque and I am head of studies of this school, and also I'm the responsible for the capstone project that you will be developing in the near future. So for me, that I come from another research area in the origin, it's been a really exciting morning. I think we are merging two different things, coming from the theoretical point of view and merging it with the application that Txus just showed us. For me, it's really fruitful, and I think that we have the future in our hands And we hope that you, as students, collaborate to reach all the goals that Txus is just pointed at us. One of the main things that I think are really important for this master program is the collaboration between companies and also university. This couldn't be possible without the collaboration of Tyris, Orobios, Altametris, and also INECO. INECO is it's a Spanish company that is currently developing digital twins and digital applications, and we think that they are one of the top-notch companies here in Spain at these fields. We always, as part of the organizing committee of the master, would like to thank you and the rest of companies for supporting us, for giving us the opportunity to collaborate on real applications on this field. This couldn't have been possible without the help of Sergio Del Pino and also Manuel Lozano, that are here today and are going to present us the next topic. Sergio holds an electronic communication degree and also a telecommunication engineer and master here from UPN, and is currently a technical developer of digital twins on telecommunication networks. And Luis is also a telecommunication, sorry if I'm wrong, but I think he's telecommunication engineer and also an air navigation master, also from UPM. With the help of both of them, they have been capable of developing a digital twin of a really sensitive building that we have in the Malaga airport. That is the one that holds the radar. I didn't know that beforehand, but I have just known that radar usage intervals are quite sensitive to environmental conditions, and that's the case for developing a digital twin of this building in order to optimize its development and also its rendimiento. Sorry, I just forgot the word. So please, this is your time. Thank you.
Good morning. Thank you very much for the introduction. We are delighted to have the opportunity to share our insights with you today and to show TWINECO, that is our digital twin for infrastructure. Some years ago, when I first heard about the concept of digital twin, I immediately realized that it brought a lot of possibilities. Through this session, we will try to show you some of these possibilities. For example, the ability to test and predict outcomes without putting the real system at risk, what is very important in our case. I often wish I could have a digital twin of my own. As I always say to my family or people who want to know what is it, I tell them that it could allows in this case me to have like a real twin, someone who could undergo medical tests or surgeries on my behalf before I do. I think it sounds pretty good. So we want to apply the same concept, the same idea to infrastructure. And we will explain how we can achieve it during this session. We will start by examining the key challenge that the infrastructure operators have to face. Then we will examine how digital twins addresses this challenge. And finally, we showcase a successful implementation as a case study. But first of all, let us introduce our company. INECO is a reference engineering and consultancy company in sustainable mobility and digital transformation. For 55 years, INECO has been developing comprehensive, innovative, and technological projects that has allowed it to advance toward a new mobility model that is more safe and sustainable. With a multidisciplinary team of more than 5,000 professionals, it has present in all the continents in which it deploys its experience and capacity to undertake projects. It extends to all the transportation sectors, such as urban mobility, railways, or aeronautics, including air navigation and airports, or maritime, road, buildings, and as well as the digital transformation sector. And INECO, as a reference in digital transformation, dedicate a significant number of hours to innovation projects, more than 30,000 of hours every year. By means of internal calls, every employee can propose their ideas for execution as an innovation project. Some of them are chosen, and finally some arrives to market. This is the case of TWINECO and other projects, other products. This is one of the aspects of our work that we enjoy the most, because the innovation is in our DNA. And why did we decide to implement a digital twin? What problems do we want to solve? To answer this question, we should give you some context first. And as I mentioned before, one of the fields where INECO undertake projects is air navigation. Air navigation is responsible for the planning, control, and management of the air traffic. So the goal is the safety, but keeping in mind minimize the delays and maximize the capacity. For example, in Spain, ENAIRE is the air navigation service provider, and air navigation has been the first field in which we have decided to implement a digital twin, although it can be used, it can be adapted for use in other contexts, such as airport or railways, or indeed whatever infrastructure or building. One of the infrastructure where a digital twin concept proves to be very beneficial is a radar that is a surveillance system using navigation that is used for detecting and tracking aircraft, and they are crucial because they provide real-time information to the air traffic controllers. Don't you think that the next year will be exciting for the engineering? I don't have any doubt about that, and this is the case in air navigation. Objectives such as capacity, safety, cost-effectiveness, sustainability involve demanding challenge that we have to deal with in air navigation. Moreover, there are hundreds of air navigation infrastructure distributed through the territory, some of them in the middle of nowhere, which implies high operating and maintenance cost. For this, it will be essential to rely on tools that help us in decision making in a more and more complex and volatile context with an increasing number of systems and information sources. Moreover, these tools should let infrastructure operators optimize their operation, keeping in mind sustainability. So, current trends of centralized information, interconnection of systems, or new technologies such as IoT, artificial intelligence, or BIM can be the best enablers for infrastructure operators. And indeed, they are implementing and deploying these technologies, although these technologies operate in separated silos. For instance, in air navigation radars of INECO, they were integrated in an IoT system in order to monitor the energy and climate systems. And on the other hand, there were BIM models, but there wasn't any relationship between them. In order to exploit the synergies of using these new technologies all together, it is necessary a solution in order to integrate them into a single system as a whole, and this is the reason why we decided to implement and deploy a digital twin. Infrastructure operators can take advantage of this concept, and we will show through an example the success case of TWINECO. As a result, TWINECO works as an integrator of information and tools based on new technologies that enable quick decision making, optimize operation, reduce environmental impact. This system let us perform immersive browsing through the three-dimensional model. Besides the information that comes from the BIM model. In addition, and I think it's one of the parts more important, is that it gives access to real-time data related to the operation of the shelter and equipment of the radar. This information is provided by sensors and a deployed IoT system, besides other information sources such as meteorological information. Consequently, TWINECO empowers infrastructure operator with a decision-making tool that enhance situational awareness during the operation by centralizing the information at a single point. For instance, it lets you know right from your desk the exact location in the shelter of a malfunctioning device, and it helps you to determine what tools you need for repairs. TWINECO also has a better performance than traditional monitoring and management system because it enables simulation and predictions, optimizing infrastructure operations, and as a consequence, it enhances maintenance efficiency, sustainability, and resilience using artificial intelligence and machine learning models for predictive maintenance, energy optimization, or the ability to simulate different contingency scenarios. For example, engineers can ask questions like, what if we increase the shelter temperature by 2 grades? I mean, how would it impact to the energy consumption or the equipment performance? Or what if the air conditioning fails? One of TWINECO's strengths lies in its flexibility and scalability, allowing the integration of additional information sources and simulation models, and adapting to evolving needs.
Okay, and now, hello everyone. Now I'm going to do a brief explanation. Okay, sorry. It's the next. Okay. First of all, we can differentiate 3 main parts of the application. One of these dedicated in the generate the user interface, commonly called the front end. Other to manage the information through the application, that's the backend. And around it, the rest of the information access services. This information comes, for example, from the IoT systems, the SCADA systems, or the sensor deployed in the building. Or, for example, other external sources of information like IMET to obtain the meteorological information of the place. Also, it's important the access to the artificial intelligence model developed and the acquisition of the 3-dimensional model coming from a BIM project and the necessary tools for interact with them. This architecture improving the performance of the application and allows a great scalability when to try to connect for new sources or new buildings. Okay, now we'll try to introduce the application by exploring its key functionalities, given a guided tour of its navigation interface through the building and the visualization of the data. In addition, we will show you the access point of the simulation tools, as well as the representations of the result generated from the artificial intelligence models. To do this, we will show you some videos using the application where you can see each of the 3 main functionalities, which are the navigation from the 3-dimensional model of the building, the real-time information windows, and the simulation tools available. In addition, we will try to describe the main characteristics of each one. And therefore, let's watch the first video. Okay, as we can observe, TWINECO show a clean and intuitive interface that highlights the three-dimensional model of the building and all the navigation options to the application, all using, for example, drop-down menus and other pop-ups for the different options and the elements of the application. In this way, users can easily navigate through the floors and on all the rooms where we can find all the devices and their respective properties. In addition, the interface provides an instant display of the essential information for the maintenance of the operation of the building. For example, user can easily check the alarm status of the equipment, painting in red in case of alarm, or as well as the climate details of each room, all clearly displayed on the 3D models, using, for example, a heat map over the room. The application provides a comprehensive view of the site's attributes from a single point. It provides information about the environment and the current status of all the equipment. And for the next, in the following video, we can see how the data of each device is displayed. Let's go it. Okay, TWINECO has the capacity to not only show limited data, it can also handle large volumes of real-time information for all equipment. The application provides some operational information windows which can display all the discrete or the analog data collected by the sensor or the IoT system deployed in the building. This capability allows us monitoring the operation of the all equipment. In the event of an error or alarm, it's easy to locate the reason of the incident. In addition, we can cross-check all the regular operation data with the maintenance actions. In essence, TWINECO can host all the pertinent information about the physical asset, making it accessible from anywhere and through a unified platform. And now, to finish, we will see the following video, in which we will see some of the simulation tools that have been developed using the artificial intelligence models. Most of them are related to achieving the sustainability objectives and the optimization and the building energy consumption. Okay. Similarly, we gain access to simulation and prediction tools that empower us to achieve objectives such as the resilience and the sustainability of the building. These tools enable us to configure and generate results from artificial intelligence models, all with a visual representation in the application. This will allow us to see the result obtained over the time represented on the three-dimensional model. Some of these tools are designed to achieve sustainability goals. For example, by optimizing the energy needs of the air conditioning equipment, basically analyzing the historical consumption data and the climatic condition of the place, and modifying some of the air conditioning parameters, such as the temperature of the climate machines. On the other hand, others have been designed to detect the impact of possible equipment failures. For example, simulating an scenario in which air conditioning equipment fails. These tools allow us to know the time it will take from the failure of the air conditioning equipment until the room reaches a temperature that we can consider dangerous for the correct performance of the radar equipment. In addition, the evolution of the room temperature over the time representing it on the three-dimensional model. In essence, these tools elevate the level of control and monitoring of infrastructures. They use real-time and historical data from the installation to make predictions and simulate scenarios that optimize its operation. And to finish, in conclusion, TWINECO is a game changer. It improves maintenance operation by centralizing the information from different sources, improving the situational awareness, and making easy the data-driven decisions. Moreover, TWINECO incorporates simulations, prediction, and optimization tools that enhance efficiency and sustainability, for example, by optimizing the air conditioning needs. Apart from that, TWINECO has the ability to perform contingency impact simulations that significantly improve the infrastructure resilience. And that's all. Thank you for joining us in this exploration of TWINECO and the world of digital twins. These technologies will revolutionize the way that we manage and optimize our infrastructures. Feel free to ask any question, of course, and we hope you found them interesting. Thank you very much.
One question. I will start with that. What is the reception of the feedback that you are receiving from public administrations when you are proposing similar projects to be developed?
We have had a strong, I must to say that INECO in this case have loved the project since the beginning. We have had a lot of help from them, and the reception has been very good. Sergio, for example, has trained a lot of engineers of INECO, and the feedback has been very positive.
Hi, I am a student from the Masters. I have two questions. first one, well, congratulations for the presentation. I like a lot. And first question is about the interface. I like a lot the interface that you made. Which technology do you use for the interface? This is the first one. And the second one is, are you going to apply this model to other domains, for example, data centers, that I think that the problem is more or less the same that you are using here? Thank you.
Okay, thank you for the question. The interface, the user interface, is a commonly web application, and we use some frameworks for the front end and some framework for the back end. A lot, for example, in this case, some of the part of the backend is in Node.js, and other parts is in Python, and the front end, or only the interface, is using the React framework. And for the second question, I think the most important part now for us to include new buildings or include new models is the model. Is to add the model is really necessary to develop a space where we can to add in our team, in our space, develop space.
And data centers is in our roadmap, and we want to use this kind of digital twin for the data centers of, for example, air navigation service provider, ENAIRE. But it's in our roadmap, and we hope to could afford this kind of projects. But it depends on the innovation department too. So, but it's obviously in our roadmap, because is the next step, to go to a bigger infrastructure. Thank you for your questions.
Next question for Rubén. Rubén is part of the BIM team of the Escuela de Caminos, and they have developed a BIM model of the escuela, of the school, which is now coming to life with a digital twin. And I'm sure that you have a lot of questions.
Well, hi, hello, thank you for your presentation. I have two questions too. The first one is related also for the front end. Have you considered, you mentioned the front end of React. Have you considered the other front-end framework like Angular, or why you choose React over Angular? And the second one is, which is the standard that the platform, or the standard related to the digital twin that the platform is able to render into the front end? Is IFC, or are Revit models, or any specific format? Thank you.
Okay. We consider React because at first we try to do an interface around the model, the 3D model, the environment of the 3D model. And React is good for do a one-page application, and this is the reason. And okay, yes. In this case, INECO have a department to develop the BIM models, and we adapted to the format that we use. In this case, is Revit.
Hi, my name is Beatriz. I'm a student too. I understand that you cannot operate with the digital twin, or you can you, if you can, depending of the results or the consulting data, you can turn off or on the lights, for example. You cannot operate, or this is a goal in the next in the future.
It's absolutely possible to do it, but not in this moment, but not for technological reason, but only for I mean, sometimes in the technical people have some kind of fears about this kind of remote systems. So we prefer in the first step only to give this kind of functionalities, not the remote control, but not for technical reasons. It's perfectly possible in this moment. It's only because we prefer not to kill the system at the beginning because of that. For the fears it could that technician could have for it.
But maybe you can use the simulation or prediction to know how to have to
Yes.
turn the lights or not.
Yes, this is what we use at this moment, the digital twin.
The human does this.
Yeah,
This question.
it could be technically possible to do it automatically and remotely, but we prefer not in this moment for this.
Okay, thank you.
Thank you very much. So this is it for the morning. I guess that our European friends are starving quite much. I would like to thank a lot to all the lecturers today for your effort coming to the escuela, particularly to Eduard and Txus who had to travel today, and especially for sharing your knowledge, which nowadays is very, very appreciated. I hope that you have enjoyed the morning, that it has been fruitful for all of you, and we hope to also be at the same level in the sessions that we will be organizing in the following days, which I know that they are quite interesting. So before we leave for lunch, the agenda this afternoon for the learners will continue. We will have a visit to the Museo Torres Quevedo, which is the origins, and you realize that it is one of the origins of artificial intelligence. I know that you will enjoy it. And then we will have a couple of lectures, one from actual UPM on entrepreneurship and innovation and around the possibilities of innovation with UPM, and another about link construction and the application of digital twins, a lecture by Onur, who just came from Istanbul a few minutes ago. So thank you for being here and for your attendance and for your lectures. Yes.
Do you take the opportunity that we all gather to have a group picture?
Yes, I think that Lucia is on that.
Lucia,
Yeah.
before everyone
Yes, we need to take pictures today after
Yes.
the visit to the museum in Torres
Exactly.
Quevedo,
Okay,
and
yes.
tomorrow with the
Yes.
capstone project.
Yes,
So,
great. Yes. And the companies, that's